Okay, in this portion, 15, 16, 17, we're going to be solving rational inequalities. So to do that, we need to make sure everything is equal to 0, or the 0 is on one side of the inequality. So let's do that first. X squared plus 4x minus 5 is greater than or equal to 0. Now we need to find the values for x that we can substitute into this expression so that every time we substitute it's greater than or equal to 0. Now greater than or equal to 0 means positive, so we want positive answers. Okay, so we're going to do this, we're going to solve this by setting up a sign chart. So we're going to set up a sign chart first by getting the factors that multiply to x squared plus 4x minus 5. So let's factor this. X and x, 5 and 1. I need a negative 5 but a positive 4. So I'll need a positive 5 and a negative 1 for my factors. Now I need to find the values for x so that when you multiply these two factors it always gives us a positive number. So the easy way to do that is to set up a sign chart. So we're going to set up a little number line for our zeros. Our zeros are the numbers that make each factor 0. So the zeros for this expression, or this inequality, is negative 5 for this and 1 for this factor. So we need to put those in order on our number line. So negative 5 comes before 1, so we'll put those on the number line that way. Now the first factor we had is x plus 5. So we'll put that there. And x minus 1 is the next factor. And then we want to know what the whole expression is, the sign of the whole expression when we multiply the x plus 5 times the x minus 1. Okay, so we're going to now put the zeros on this number line in this chart for the correct factors. So the 0 for x plus 5 is negative 5, and the 0 for x minus 1 is 1. So I'll put our zeros there. Now if I substituted in any number less than negative 5 into this expression, I'm going to get a negative. So this sign is a negative here. If I go above negative 5, I'm going to end up with a positive. So these two boxes have positives in them. So over here, same rationale. If I substitute anything below the 0, I'm going to get negatives, and anything above the 0, I'm going to get positives. Now these signs right here are found by multiplying these two factors together. See, x plus 5 times x minus 1. I'm multiplying these two together. So when you multiply a negative times a negative, you're going to get a positive. A positive times a negative is a negative, and a positive times a positive is a positive. Now these are the signs for the solution. Now we need our solution to be greater than 0, so that's positive. So I need this and this interval for our solutions. Now we need to go back and look at our sign. It can be equal to the 0 because it's greater than or equal to. So the negative 5 and the 1 can be in the solution. So the interval that makes this equation true, or inequality true, is from negative infinity up to negative 5, including 5, with a union of 1, 1's included because again it can be equal to the 0, and all the way up to positive infinity. So any of these numbers that are in these two intervals can be solutions to this inequality. Okay, number 16, we need to factor the numerator and the denominator to get its factors so we can find the zeros. So we can factor x squared plus 2x by taking out the GCF of x. So we get x times x plus 2. And this denominator is going to be a difference of two squares, x plus 3 and x minus 3. Okay, so we have it already equal to 0, so we're good. We can just put all the zeros on our number line. Here's a 0, 0 for this 0, negative 2, 3, and negative 3. So the lowest number is negative 3. So we'll put a negative 3 here. Next one is negative 2. Then we have a 0 and a 3. So that's our number line. And then our factors. We have an x, we have an x plus 2, we have an x minus 3, and then we have an x plus 3, and then we have the entire expression, which is just x squared plus 2x over x squared minus 9. Okay, let's finish up this chart. The 0 for x is 0. The 0 for x plus 2 is negative 2. And this one is 3. This 0 is negative 3. And so everything to the left are going to be negatives, and to the right are going to be positives of each 0. Okay, so let's multiply down. We have 2 negatives that turn into a positive, and another negative, and then positive. So we have 4, that's even number, so it's going to be positive. Negative, odd number of negative signs stays negative. This one's going to be positive because there's an even number of negative signs. This one will stay negative, and this one will stay positive. Now, the question in the original question is we want our function to be less than 0. Less than 0 means negative. So we want all the negative intervals, which are those two. And it's greater, less than or equal to, so the 0 again can be included. So our solution is going to be negative 3 to negative 2 union 0 to 3. Now, notice I said that the zeros can be included. Well, I forgot to mention that the 3 and the negative 3 cannot be included because 3 and negative 3 are the zeros for the denominator, and we can never have 0 in the denominator, so they are not included. The negative 3 and the 3 are not included because of the restrictions from our domain. In our domain, we cannot have x equaling 3 or negative 3. So our solution is the interval between negative 3 and 2, including negative 2 but not including negative 3, union 0, including 0 but not including 3.